we need to see what exactly noise is, किस types की noise हो सकती है जो हम ऑब्जर्व करने की कोशिश कर रहे हैं जिसकी वजह से हमारे सिस्टम में प्रॉब्लम आ सकती है हमारा सिस्टम इफेक्ट होगा we need to understand what exactly noise is और हम इसको कैसे ऑब्जर्व करें कैसे एनालाइज करें so noise is an unwanted and unpredictable random signal हम लोग काफी टाइम से बात करते आ रहे हैं that is going to affect the carrier or the modulated signal right so that is a noise signal हमारे मॉड्यूलेशन टेक्निक्स में दो आइटम्स होते हैं we have a carrier wave and we have a modulation wave right and there is something called as a modulated signal जो हमारा final signal prepare होके आता है after the modulation of carrier and the message so हमारी जो ये noise quantity that is unpredictable and random and of course unwanted. We don't want noise in our system or we want minimum noise in our system. ये हमारे कैरियर को या फुल मॉड्यूलेटेड सिग्नल को अफेक्ट कर सकते हैं so what kind of noise we can have or what sources of noise do we have first is a natural source second is man-made and there is another important type of noise that is the fundamental or internal source of so if we talk about the natural source what is natural source it is originated from the environmental or extraterrestrial space due to solar flares, cosmic radiations, electronic storms, etc. तो ये हमारा एक natural source है. Whenever your signal is transmitted, whenever it is moving in the free space, being communicated, there can be natural sources of this. इसमें हम कुछ नहीं कर सकते from the environment factors. Second is the man-made noise. So what is man-made noise exactly? It's generated due to make and break in the process of current carrying circuit. That means जो हमारा जहाँ से भी सिग्नल पास कर रहा है wherever it is being communicated there will be a lot of noise that affects the circuit. It can be some motors, some welding machines, some other moving parts. It can be anything. So that is man-made noise. Then third is the fundamental or internal noise. So this is the kind of noise that is actually generated within the electronic equipment. So हम इसको fundamental और internal noise इसीलिए कहते हैं because this is originated inside the equipment. ये एक equipment के अंदर originate हुई है. So it is not always possible to reduce or remove the source क्योंकि ये इस equipment का integral part है, important part है. Nothing can be done about this noise. But yes, we can minimize this by properly designing the electronic circuit. And अगर एक poorly designed circuit है, poorly designed system या device है, it may have lot of fundamental or internal noise that is going to affect the quality of performance of the system. But yes, अगर हम इसको properly थोड़ा सा analyze करें, थोड़ा सा इसको design अच्छे से करें, then this noise can be minimized. It cannot be made zero as such, but yes, it can be minimized to a certain extent. So, further fundamental noise source produce different types of noise. तो हम इनको fundamental noise sources में categorize करते हैं. So, there is something called as thermal noise or sensitivity. So, due to the random motion of electrons within the conductor, thermal energy is generated. Because of that, we get thermal. So, ये भी type की noise है. That is happening because of the random motion of electrons within the conducting wire or in the conducting system. Right? इसको हम Johnson noise भी कहते हैं. So, the formula for this energy is the thermal energy noise is given by 4 kT P R, right? So ये आप लोगों ने already पढ़ा हुआ है. What are all these variables? You know T is the temperature, P is the bandwidth, R is the resistance, and K is the Boltzmann constant, right? So अगर आप इसमें देखो इस formula में, so actually K is going to be constant. B भी अगर मैं एक system की बात करूँ तो bandwidth is also going to be mostly constant and resistance. So your this thermal noise or Gaussian noise it greatly varies with your square root of temperature. जितना temperature system का increase होगा उतना आपका यहाँ पर random motion बढ़ेगा obviously and there will be more thermal noise or Gaussian noise. So it is again very important कि आपके system में proper cooling maintain हो क्योंकि आपकी device है क्योंकि आपका conductor है जहाँ से communication हो रहा है proper cooling is maintained so that the temperature does not increase unnecessarily causing the increase in thermal noise. Then there is something called as short noise. What is short noise? It is produced due to the random variation in the arrival of carrier at the end. So it is generally produced in the amplifying device. So this is quite straightforward. Arrival of carrier signal at the output. Then there is something called as partition noise. So it is generated when the current gets divided into two or more paths or due to some random fluctuation in current division. तो हमारा जो भी सिस्टम है इलेक्ट्रिकल systems आप लोगों ने पढ़े ही हैं. Whenever there is current involved, it can travel through multiple branches or paths. So whenever a current gets divided or whenever there is some fluctuation in current division, whatever noise is produced to that is called partition. Then there is something called as flicker noise. So in semiconductor, this kind of noise is generated due to fluctuations in the carrier, that is electron or holes density. So you know semiconductors have electrons and holes. Flicker noise is produced due to the fluctuation in the carrier density of either electrons or holes. These generally appear due to the low frequency operation below your kilohertz range. So हम इसको 1 by f noise भी कहते हैं और low frequency noise भी कहते हैं और it mostly appears due to low frequency operation below your kilohertz. तो ये आपका megahertz या gigahertz में नहीं जाएगा below few kilohertz की आपकी ये noise generate होती है. So it is low frequency noise also called as 1 by f noise. Next is something that is called the transit noise. ये almost इसका opposite रहता है. So it is observed at a very high frequency, and that is why we also call it as high frequency. So these are most of the categories of noise that we have to consider whenever we are dealing with noise in a communication system, or in fact noise in any electronic system. But yes, when we are talking about communication systems, we have all these kinds of noise. And internal noise components are very important because अगर मैं natural और man-made noise की बात करूँ तो हम इसमें ऐसा कुछ नहीं कर सकते. It depends on the environment, it depends on the area surrounding the communication device जहाँ पे भी communication हो रहा है, इसमें हम कुछ नहीं कर सकते. It is totally random, we cannot reduce it also. कुछ हम ऑप्टिमाइजेशन करके इसको रिड्यूस भी कर सकते हैं. ये जो आगे है नॉइज वो आगे नहीं आएगी. बट मेकिंग सर्टेन एडजस्टमेंट्स, मेकिंग डिजाइन बेटर, वी कैन डेफिनेटली रिड्यूस आवर इंटरनल नॉइज कैटेगरीज, थर्मल नॉइज, शॉर्ट नॉइज, फ्लिकर नॉइज एंड ट्रांजिट. So how do we define that noise? It can be defined as the noise whose PSD, that is power spectral density, is going to be uniform over the entire frequency range. So if you remember, हम लोगों ने एक uniform frequency distribution पढ़ा था. ठीक है? There are different types of noise available बट हम एक वाइट गॉसियन नॉइज को कैसे डिफाइन करते हैं विद रिस्पेक्ट टू द पीएसटी। तो अभी मैंने बताया था गॉसियन प्रोसेस का नॉर्मल डिस्ट्रीब्यूशन होता है, राइट? तो अगर हम एक नॉइज कंसिडर करें इट इज विच इज अ गॉसियन नॉइज, इट इज गोइंग टू हैव दिस काइंड ऑफ पीएसटी बेल शेप। बट अगर मैं उसको वाइट गॉसियन नॉइज का नाम दे रहा हूँ, then you can see here we are going to have our PST, that is your probability distribution function. It will be, sorry, PST will be uniform, that is it is going to be constant along your this axis, horizontal axis. तो आप देख सकते हैं यहाँ पर एकदम constant है, so it is something like this only. अगर मैं दो पॉइंट्स के बीच में बात करूँ, so it is going to be something like this, the PST for white Gaussian noise. Alright, and the value for the PST is given by this n naught by 2. So this is also a fixed formula. अभी हम इसको डिस्कस करते हैं what exactly this is. So you can see here, अब हम जितने भी इलेक्ट्रॉनिक सिस्टम्स और कम्युनिकेशन सिस्टम्स की बात करें, अगर हम अज्यूम करके चलें कि हमारी जो नॉइज है दैट इज अ WGN, या हमारा जो भी चैनल है इट इज अ WGN चैनल, वाइट गॉसियन नॉइज चैनल, then lot of analysis and calculations become easier. It will be very easy to approximate how the noise is going to affect our system. Yes, it will not be 100% accurate, but at least कभी तो हम start करेंगे, कहीं हमें एक थोड़ा सा approximation मिलेगा कि हमारी noise किस type से behave करेगी और how is it going to affect our system. So PST of the white noise is going to be uniform over the entire frequency range. So why do we call it as a white noise exactly? Okay? So white noise, it contains all the frequency components in equal portions. जैसे हम अपनी white light में देखते हैं all the colors जितने भी हमारे colors होते हैं उसका equal proportion होता है. So the same way हम लोग white noise को लेके चलते हैं because it contains all the frequency components in equal portions or proportions. And why is it Gaussian noise? Because you can see here it has a Gaussian distribution PDF of white noise. तो हमारा जो Gaussian distribution होता है अगर हम इसको uniform ले लें then we are going to get a uniform distribution. So इसीलिए हम इसको white Gaussian noise का नाम देते हैं. Alright. Again अभी हम जैसे बात कर रहे हैं कि it's all fixed here if we assume the kind of noise that we have. If it is going to be random noise, we will have to analyze it, we'll have to observe it, उसका हमारा probability density distribution function निकालना पड़ेगा, उसका PST निकालना पड़ेगा, and that is going to cause a lot of complications in the system. But अगर मैं PST of white noise, क्योंकि हमने white Gaussian noise इसको assume किया हुआ है, and we take the PST of white noise as some fixed quantity. Fixed quantity मतलब it will also depend on certain variables, but its formula will be given by n naught by 2 or eta naught by 2. So this is going to be the PST of white noise जो कि हमारा uniform distribution follow करेगा, right? Where how do we define n naught? You can see here it is k, that is the Boltzmann constant, and this is called as the equivalent noise temperature of the system or of the channel जिससे भी आपका noise pass हो, right? So we will be using this formula for analyzing our noise in the system. Considering that the noise that we have in the system it is white Gaussian noise. Function, अगर हम probability density function की बात करते हैं, and if we are talking about power spectral density then it is going to be uniform with this formula. ये दो points बस आपको ध्यान रखना है अगर complicated लग रहा हो topic. So PSD is going to be uniform over the entire frequency range, and the density function or the distribution function, probability distribution function, it is going to be a Gaussian nature. Alright. So if you find this topic difficult, then just remember these two points. And this is mostly used in all your calculations as well, because we are going to be taking this formula into consideration. जो भी हम noise को assume करके चलेंगे, if it is a white Gaussian noise, then we are going to assume this.